Okay. Now, I will do example 5. Let me see what's in example 5. I have another system here. Find out the transfer function of the following. This is similar to the previous function somehow. I have uh, two cascaded circuits, one to the right with V out and one to the left with Vn. And I have V1, this V1 here. Let me increase the font a little bit so we can see it. So this is V1, and let me actually color it, which is the temporary V1. That's the output of the function to the left here. And this function Vn, I have Z2. Here, this is Z2. And I will call this Z2, I'll call it Z12, Z12 as I did before. And this Z1, I will call it Z11 as I did before. So this is, and here I have, this is, that's my Z2, which is my second. This is Z2, 2, and this is Z21. That's 32. I want to make this as visible as possible. Okay. All right. So now, still again, I will do V out versus V1, which is minus Z 22. Okay, let me, I'm working it out here. So this is my first circuit, this is my second circuit. Let's do the math together. Okay. Okay. So now I'll do the V. So it's the V1, V out. So this is the V out right here. Divide by V1. And let me increase the font again for 32. So V out divided by V1 equals minus RF divided by RM, or RM, actually it's called RM. Okay, so that's the first V out divided by V1. Now I need to find V1 so I can work out the example. So now V out in terms of V1, I found this out, with this minus Z2 divided by Z1. Now I need to find the V1 divided by Vn, okay, which is this n right here. Okay. I'm talking about this V out, this Vn related to this V1. That's what I'm talking about here. That's where this transfer function of the first circuit. So this is equal to minus Z2, which is R2 divided by R2. I'll do this directly. This is Z2 is R2 divided by 1 plus R2C2. This is R2 divided by 1 plus R2 C2S, this one, divided by and there has to be one more bracket here. Let's make it curly bracket, square bracket, divided by Z1. Now Z1, I have to add these together, which is R1. This is R1 because they are in series, plus the transformation of C1, which is 1 divided by C1S. 1 divided by C1S. That's how we do the transformation Okay, so now I don't need this anymore. So now I have V out in terms of V1, V1 in terms of Vn. I will get the value V1 here from this equation 1. It's called equation 1. Let's call this equation 2. So using equation 1, I will write V1 equals to so this is V1 V out divided by V1 equals minus RF divided by Rn. So V1 now equals minus RF times minus RF equal V out times. So V1 equals V out V1 equal minus RF divided by Rn. V out Rn equals V1 RF. V1 equals minus V out Rn divided by Rf. So V1 equals minus, because there is minus there, V out minus V out times Rn and all divided by Rf. This is what V1 is. Now, I substitute V1 in this in equation 2. Substitute V1 in 2. And I get the value of V1, which is this one right here. So this is right here. All divide, and let me make this square brackets, and this is square brackets. So this is the value V1, all of this. All of this is divided by Vn. So in fact, I can make the Vn Vn. I can eliminate this without losing any accuracy. All of this is equal to this right stuff right here. Okay, so now I have this equation that has V out and V in, then I can find the transfer function, which is, I think I have it here. No, you can do the transfer function by dividing V out by Vn. You keep V out Vn on this left hand side, you keep this right side, and you multiply it by Rf on the top and Rn in the bottom, and then you will get the transfer function. So this is the this example number 5 solved, and I will stop the recording here and do